So when you think about evidence of evolution or evidence of common ancestry, so there are a few different kinds of evidence of evolution. One of them is fossil evidence. We can look at DNA evidence. The evidence that we're looking at in this particular lesson is the similarity in structure between living organisms. This is something they call homologous structures. Basically the idea that different organisms will have very similar structures. In this case, we're talking about the bone structures in the hand and in the arm of a number of mammals. And so in this lesson, rather than just present that on the table, that this is evidence of common ancestry, we start by showing pieces of that evidence to students and seeing what conclusions and questions they come up with themselves. I'm going to start with an image. What you want to do is turn to a partner here and talk about what do you notice. I started by showing the group an image of the bones from the flipper of a whale. I asked the group to make observations and then come up with questions. They came up with a lot of really interesting observations and questions. It is an opportunity for students to share background knowledge, generate ideas before we start presenting them with information.
Would that be a place for cartilage? Is it for joints? Is it literally metal that's holding the pieces of bone together?
Yeah, it looks like a line holding the limbs together.
Before I gave them any more clues, I asked, what animal do you think this might be from? And we generated a list of what those animals could be. And then what animals do you know it's not from? So we made both of those lists, and then I started giving clues.
We were talking about how the short bones, so it must be a hardy animal, so meaning a bigger animal, because it's obviously moving a lot of weight or pushing. Because, I mean, the bones in our hands are long and lean, so those are really short and thick.
Right? These are saying these are short and thick, but it must be supporting a lot of weight.
Supporting a lot of weight and muscle.
Interesting. I'm going to give you guys a little piece of information here. So one of the clues I gave shows a group of children sitting around these same kind of bones on the beach. I think the next clue showed the full skeleton. Earlier people had guessed whale, but at that point many people thought it was a whale. But other people still thought, well, maybe it's not a whale. Maybe this is something prehistoric. And the final clue was the song, a whale song. And then the reveal is to show the whale bone inside the drawing of a whale. Anyone still feel like this is an extinct animal? Okay. It is a whale. I think it's kind of shocking. When you look at these bones in the flipper of a whale, it is so clearly related to us. And it's in this animal that is just so incredibly different from us. Wow. Take a look at this for a second. Think about it silently. The next step in the lesson is to show students images with different animals, the bone structure in their arms. And so we have the whale, and we have a human, we have a bat, a lizard, and a bird. I again ask the students to identify what animal those skeletons are from. And it's not immediately obvious. The lizard is pretty difficult to figure out. I'd say the bird is not immediately obvious that it's the same structure. The bat hand is unbelievable because it's sort of, these fingers are super long. It looks like Edward Scissorhands or something. And the next part of the lesson after that is to start to ask people, so why? Why is there such similarity in the bone structures of such very different animals? In my mind, I kind of want that common ancestor question to come from the students. Is it possible? Like, why is this? What possible explanation could there be for the fact that we all have hands? So our approach with this series of lessons was to think about the topic of evolution through natural selection from Darwin's point of view. We wanted students to be in the position of analyzing the evidence themselves, imagining themselves as scientists. In this particular lesson, we were presenting evidence to them in the form of photographs of skeletons. We're asking them to make observations about what they're seeing, and then start to think about questions, and then come up with some hypotheses about why this might be true. And in this case, we're hoping that one of the main questions that might come up is it possible that we all come from one common ancestor?